Welcome to the first section of the new training videos of UCP Africa's ScanIT core logging software. In this video series, we'll be highlighting a number of ways that this innovative software can save you time in obtaining important and precise data from your borehole core samples. The goal of these videos is to assist our clients in getting the most out of using ScanIT and to log their boreholes in an efficient and innovative fashion with the overall goal of improving the quality of data acquisition from your orientated core samples. So, let's start at the beginning and let's create a new borehole. We do this by clicking the File button, which is situated on the top right of the screen. Clicking this will generate a drop-down menu where we can select New Borehole. This is the page where we will begin inserting all of the information relating to this specific borehole. Complete borehole ID, the name of the responsible geologist, the name of the drilling company and supervisor details, whether the orientation line was scribed on the core represents the top or bottom of the core sample, which type of orientation tool was used, the coordinate system for the indicated collar coordinates along with the planned inclination and azimuth of your borehole. Next, the user can select if they would like the software to automatically detect any possible core breaks or core depth marker information. Then, when you're ready, click Create Borehole, where you will then be prompted to select a save location for this project. Welcome to the ScanIT user interface, where the next requirement would be to add the core tray photographs relating to this borehole. We do this by clicking Image and Add Image from the drop-down menu. We then will be able to locate and select the core tray photographs relating to this borehole. Select which images you would like to be placed into ScanIT and click Open. ScanIT will then import each image in chronological order into the program. Each image is automatically cropped and scanned for any possible force breaks and core depth markers. Core depth markers are read using optical character recognition and will start the process of depth marking each run inside your core tray. While this has been processed, let's have a look at the various user preferences which can be selected by clicking BH Data and then Preferences from the drop-down. Here the user can select meter marking tolerances if they would like to view adjacent core trays, edit the orientation tool information and machine learning options. Clicking Save will set your user preferences for the borehole. However, these can be changed at any time. Now we can start to log the borehole. By clicking a core tray from the thumbnail on the left-hand side of the screen, we will be able to view each core tray in more detail. First, we need to confirm that the core diameter was correctly identified by the red lines on each side of the core inside each channel. This can be corrected should there be any misalignment, simply by holding the Shift key and clicking on the red line and sliding it to match the core diameter. Once we are happy that the red lines are correct, we can then start to depth reference each run of the borehole. Starting with the first channel and the first core tray, we can see that the start depth of the first run has been indicated at 2 meters and ending in 7.04 meters, where ScanIT has calculated a provisional loss of 7.2 centimeters for the run. If we start at the first depth marker, we can see that the precise location of the start line has not been correctly positioned. We can correct this by clicking and dragging the core break line to the edge of the core and then by dragging the core depth marker green vertical line to match. The force break now visible can be noted by selecting the force break keyboard shortcut key F or by clicking Mark and Force Break from the drop-down. You will see a change in the action bar on the top left of the screen, and then by clicking on each edge of the break to bring up the yellow force break line. Here you can clearly see two different rulers, one red and another blue. These are downhole and uphole rulers from each core depth marker. In order for these two rulers to align, we first need to confirm that each break identified in the run has been noted correctly. We can then pan along the image by right-clicking and dragging the image along so that we can assess each channel and confirm and correct each break accordingly. Should a break be incorrect, we can correct it by clicking on one side of the yellow line and dragging it into place. Should it be a falsely identified break, it can quickly be removed by holding the control button and clicking the yellow line to remove it. Should you locate any natural breaks, the forced brake yellow line can easily be changed to a blue natural brake line by right-clicking the yellow line itself. This will allow the geologist to quickly identify any natural breaks that he may want to log down line. You may have noticed that while we were correcting the various breaks, that the two rulers have now changed to one solid black line. This prompts us to believe that the run has been depth referenced. Please ensure that all breaks have been correctly assigned, as there may be situations where a gain was established in a run. We then repeat this process for each run along the length of the borehole. If we look at the next core depth marker, shown to be 14.44 meters, with a provisional calculated loss indicated of 27.1 centimeters, we first need to ensure that all the gaps along the run have been correctly identified. So, starting below the previous core depth marker, we can pan along each channel to confirm each gap. Again, we can remove any incorrect gaps by holding the control button and by clicking the incorrect gaps while we are panning along to confirm each gap is correct. Considering the scale of the calculated loss in this run, we must take note of any possible signs of potential core loss along the run. Here, we look for stubs of core which are not matching up or evidence of grinding on the core itself. We can see some irregularities, and by pressing the L key or by clicking Mark and then Loss from the drop-down menu, we can note possible locations where core loss may have occurred. Once all the gaps have been identified, we can see that a loss of 29 centimeters has been calculated by ScanIT. We would need to allocate this loss, and in this case, we will evenly allocate the calculated loss to each previously identified loss location. This is done by right-clicking the orange loss line and typing in the amount of core lost. Once the calculated loss has been allocated, the rulers will once again change to the single black line showing the 10 centimeter increments and indicating that the run has been correctly depth referenced. We can then move on to the next core depth mark, shown here to be 18.89 meters on the core block. However, we can see that ScanIT has read this core block incorrectly and noted the depth as 18.84 meters. This can easily be amended and corrected by right-clicking the green vertical line and correcting the error. We once again pan the run and correct any breaks, and as you can see, once corrected, the black ruler shows that the run has been correctly depth referenced. This process will need to be repeated along the entirety of the borehole and will ensure that any depths of any recorded features are precise and accurate. Please join us in the next video on how to record feature information.